This section is taken between the right and left ventricle. The fibrous skeleton through here insulates the atria from the ventricle to prevent any uncontrollable spreading of the impulses. At this low magnification, notice an area that has pale pink stained clusters of cells. This is the atrioventricular bundle or bundle of His. Now at this high magnification, note that they appear very different from both the cardiomyocytes of the atrium over here and the ventricle over here. This is a section of the interventricular septum cut horizontally. It enables me to show you the specialised type of cardiac muscle cell, the Purkinje fibre, which I said earlier is a major component of the conduction system of the heart. Because the interventricular septum is within the heart, both sides of the septum you see are covered with endocardium, as they will be the lining of the right and the left ventricle. Purkinje fibres can be seen just under the endocardium lining both ventricles in this tiny small area I'm pointing out here. The Purkinje fibres, cut transversely, appear subendocardial on both sides. Bands of them run from the atrioventricular node all the way down along the interventricular septum to the apex of the heart to make the ventricles contract from the bottom up. They may be distinguished from normal cardiac muscle cells by the following criteria, and these will be apparent if you view this image. Firstly, Purkinje fibres are wider and lighter staining in hematoxin and eosin. Except for the nucleus, the central part of a Purkinje fibre appears empty in hematoxin and eosin stain. This is due to the abundance of glycogen, which does not stain well in hematoxin and eosin. Myofibrils are confined to the periphery of a Purkinje fibre, hence the minimal eosinophilic stain in this region. Purkinje fibres are often arranged in intimate groups of 4 or 5. Such a group is surrounded by a small amount of connective tissue. And lastly, a substantial portion of Purkinje fibres have 2 nuclei.